Hello and welcome to another Sam Labs webinar, today we're going to be looking at how Sam Labs can augment your Makerspace and how you can actually build and set up a Makerspace with Sam Labs as one of the tools. I'm going to be doing a project with you today, showing you how you can integrate Sam Labs with other common Makerspace tools, but I'll also be giving you a bit of advice on what kinds of tools and equipment and materials would be useful to include in your Makerspace if you're setting one up from the start. So for those of you who don't know, Sam Labs is a London-based edtech company focused on producing the most engaging STEAM solutions in the market, where you can learn the fundamentals of programming while you're applying that knowledge into all different areas of STEAM. Now, the STEAM is really important for us because the A implies creativity, and being here in this makerspace, it's all about creativity. It's about applying that knowledge, learning about things by doing. So we're broadcasting live from the Sam Labs Makerspace in East London today, down in our basement underneath the office. You can see some of the great tools that we have over here. Today I'm going to be building a simpler project. I'm not going to be jumping in and using any of those tools live, but I'm going to be showing you some of the cool projects and some of the outcomes of using these tools earlier in the week. So I want to jump in to talking a bit about those materials that you can use. Now, every makerspace is different, and it's really important to recognize this. There isn't a one-size-fits-all. There will be different makerspace for different applications, and the term makerspace really is more of an umbrella term. So the number one thing that you need to do if you're considering building a makerspace or you're looking to build a makerspace and you want to know what materials to put in it is think about who's going to be using this makerspace and what are they going to be doing with it. And this is really important to understand from the beginning because you don't necessarily need to buy hundreds of expensive 3D printers or all sorts of fancy tools if actually at the end of the day, it's going to be used in quite simple applications. And vice versa, if you want to build some really ambitious engineering projects, you want to make sure that you have the right equipment there that allows you to do that. So I want to talk through some of the more basic tools that we love and we always recommend to have as a baseline, and then some of the more advanced ones that you might want to get into if you're feeling a bit ambitious. So let's start with the basics. The maker movement comes out of this whole mentality of crafting, creating, building, constructing, and making. And some of the best materials for those kind of activities are often the simplest materials. So if you're going to be building a makerspace, the first thing you need is going to be things like craft paper, pencils, color markers, stickers, glue, hot glue guns, essential, pipe cleaners, pom-poms, all these like really fun traditional craft materials are absolutely key. Even though we've got great technology and things that you can do programming within makerspaces, it's always fun to have those really kind of colorful, creative elements as well. And that means that for kids coming in as well, they're not walking into kind of a futuristic spaceship lab. They're walking into a familiar environment with materials that they would know. If you think from a cost point of view as well, you always want to make sure to bulk up with loads of those great accessible materials like the craft papers and so on, so you really have a lot to work with. So that's number one. A second one that's really useful is balsa wood. So if you want to start building constructions and kind of physical projects, balsa wood is really easy to work with. It cuts really easily, but it gives enough structural integrity. So it can be a fantastic tool for kids to really kind of get stuck in and build things themselves as well. And this, by the way, is for makerspace that be used by kids all the way down to elementary school. We would recommend kind of having this selection. Now, another favorite of ours, of course, is another kind of building material, such as Lego, where you have something physical they can construct, something that's familiar, and again, kids know how to use it, and they're jumping straight into familiar environments. Beyond that, if you want to look at some of the more advanced things, you might want to look into 3D printers. This has been a huge buzzword the last few years. Everyone's been talking about 3D printers. For those of you who don't know what 3D printers are, they are machines. There's one just behind me here. They look really fancy. But what they actually do is they extrude and melt and then set a plastic. And that's it. So basically, it's just drawing in 3D using a plastic filament. And then as that sets, you can then create all these different 3D shapes. There's some of them on the market that are really affordable, that might have a bit more of a coarse finish to them. You get some really high-end ones that can produce a beautiful polished finish. We typically recommend, especially within schools, to go slightly more towards the cheaper end, because then it just means that it doesn't really matter if one breaks, if something happens to it, then you can easily replace it. And for the type of projects you're going to be doing, something like a MakerBot or an Ultimaker, that kind of level would be perfect for the kind of uses you have. Another common tool that people hear about, and that's one of these buzzwords, is laser cutters. And laser cutter basically is a laser that can cut different kinds of materials. You can cut paper, you can cut wood, you can cut plexiglass, you can cut perspex. All different kinds of flat materials can then be cut using input files. And this allows you to create really cool 2D shapes that then can be built into 3D shapes. So my favorite example of this is these kind of dinosaur jigsaw puzzles that you can get at natural history museums. You could recreate those kind of projects with laser cutters as well. I'll go into a few more materials at the end of this presentation as well, where I'm going to be showing some of the ones that work really well with SamLabs. But the next thing that you need to think about is, as I mentioned, the kind of projects you're going to be doing and how are you going to be using these tools. And the core of all of this is the design process. It's really understanding how do you approach these things. You don't just kind of run amok and start picking things off the shelf and start making whatever. You need to set the right kind of context. You need to give the right kind of challenge and then allow the kids to follow the design process. And so for us, we always start with that context of the challenge. So, for example, we could look at smart cities, right? So we might be exploring smart cities in our school. And it's a great theme because it covers quite a lot of different areas. There's a lot of different subsets of that you can look into, things like environmental efficiency. You can look into self-driving cars. You can look into traffic systems. You can look into smart lighting systems. You can look into a whole range of different projects that all fit within the same theme. So once you've got kind of a theme that you want to explore, this gives constraints. And it's often said that the best ideas and the best design work comes when the right constraints are applied. And so once you've got that constraint, you can then start digging into a bit more specifically what you want to go for. The way that we like to do it is always through problem solving as well. So you ask the students to identify problems, something that they might want to explore, something that they might want to solve. So in this instance, it could be within a smart city, how do we stop the cars crashing into each other? Well, you might be coming from a place where it's a small rural town, there's no traffic lights, so you need some sort of a system to control the cars. And so traffic light would be a fantastic way to actually regulate the traffic. Now, once you've started actually narrowing in on one of these ideas, you can then start thinking about what goes into this project, right? What are the different inputs that you need? What are the different outputs you might want to get? And what's the logic that works in between? And so with a traffic light, you might want to say, okay, we need a regular system or time kind of signal going in that can change the color of the light. You need a physical object to indicate what the right thing is to do. So there's an element of physicality there. You need some sort of indicator. And as we all know, traffic lights use different colors as those indicators. We'll have a red, an orange or yellow, and a green light. And that communicates that message. That's kind of the logic and the physical side of it. And the output is then the information that the drivers in this town would have, where they know whether or not they can drive, depending on where they are in that traffic system. So there's actually quite a lot of really nice ideas that are baked into this. So if you take one step back, you've got that challenge, you've got that kind of theme that you're going for, you've got a problem that you want to solve, you've got an understanding of the different kinds of inputs that you want, you've got the understanding of the logic that you might want to employ in the middle and the kind of outputs you want, and you have some idea of the kind of physical elements that are involved as well. In a traditional traffic light, there would be things like wires and light bulbs and so on. Today, we're going to be using SamLabs for this. We're going to be using our blocks to build this project. But I feel like we've got enough of those different elements that we can actually piece together and say, well, this would be a project that could be a great makerspace project. And as you'll see at the end of it as well, it's a great starting point. And if you have students working on different aspects of this smart city theme, you can actually combine them all together and start integrating them. So you have different projects within the same theme working together, working alongside each other. And that actually paints quite a vivid picture. So for this traffic light project, we've gone through that design process. We've thought about the problem we want to address. We've looked into different elements we need to design. And now we can actually start going into that project. Now, if you're building a maker project using SamLabs, there's a few different elements to it. There's the planning side of sketching out, coming up with ideas, thinking through it. There's the programming side where you're actually making the physical connections, the virtual connections on the screen. You're actually doing the programming within the SamSpace app. And you've got the physical side, we actually build the project. So the first thing we talked about was that process. The next thing we're going to do is jump into the programming, and I'm going to show you how we can actually program a traffic light using SamLabs. And then I'm going to show you how you can actually build a physical project out of this. So you have a little tabletop, cool, awesome traffic light project that you can have running next to your computer. So we're going to jump in and share my screen. And so let me just find out where to do that. There we go. And today, as I mentioned, I'm using the SamSpace app. which is available across devices. I'm actually on a Windows 10 laptop, so download from Windows App Store. You can also download it on your iPad, on MacBooks, across all different platforms as well. So it really works across a range of different devices. If you have any questions about which devices it works best on, feel free to check out our website and the FAQ, and you'll find all the information there. So I've actually gone through and prepared some of my blocks. This is part of the lesson preparation. It took a few minutes for me to prepare that, but that means that I've got these blocks ready to go. And I'm just going to do a little hack here so that you can see me and follow what I'm doing physically. So I've got my camera block that I've dragged onto the screen. I'm going to zoom out a little bit, not all the way. And if I open up my camera block here, yes, we want to make sure that I can access the camera. You'll be able to see me, but I'm not going to leave this open the whole time, but I will be referring back to this camera every now and again just to show you what's going on. So rather than jumping between Sam's Space and back into the live webinar broadcast, I'm just going to be showing you this every now and again. So I'm back out of my camera here. For those of you that have not used Sam's Space before, I'm just going to talk you through a couple of the elements that we have here. This main canvas in the middle, this white space, yeah, this is where we're going to be doing all the programming. So the canvas really is the heart of the app. This is where all the projects come to life. This is where you're doing all your connections and you're building all those logical things. Down at the bottom here, we have our toolbar, which includes my blocks that I've paired. So I've got a button, an RGB LED or a light, and 2 DC motors. But we also have over 40 different software features that you can combine with the project as well. And going all the way over to the end here, we have the full range of sleeping blocks that we could also use if we were simulating a project. But so what I'm going to do now is move my camera up to the side, and I'm going to start building a project using my button as an input and my RGB LED as an output. So grabbing these blocks, I can drag them onto my canvas like so. And you can see that these blocks then have a little color next to them. I should probably zoom in a little bit, so apologies for this. There we go. And as you can see, there's a really nice visual aspect of SamLabs, so the Sam Space app. The button here looks like the button block, and the light looks like the light. Now, if you look at this color of the dot next to the button, you can see that this is kind of a pink color, and the one next to the light is an orange color. So if I go back into my camera here, you can see that the color on the side of the blocks corresponds to the color on the app as well. So it might be a little bit too hard to see in this light, but trust me that those are showing the same colors. So right away, there's a nice correlation between what's happening physically and what's happening digitally. And this is really key to giving that intuitive first starting point into programming. Now, to build a traffic light, what we need to be able to do is to show different colors of light on this RGB LED. I could build a project with 3 RGB blocks, and have one of them be each color. But I think it's a bit more of a fun challenge if you make the same color, the same block change different colors. So for this, I'm going to have to drag on a few different colors that I can send to the light. So what I'm going to do is scroll over to my RGB LED section. Here we got the color block, and I'm going to drag on 3 of these blocks. Now, what I really like about this project again is that I can actually position things on the app that look like the actual project we're building. So in this case, this starts becoming a bit reminiscent of a traffic light, where we can have a red color at the top, we can have a yellow one in the middle, and a green at the bottom. But how do we change the color? Well, to do that, I go into this settings symbol here, and I can choose any color I want on this color wheel. And as soon as I press done, this color block is now programmed to be that color. I can go into the second one, I can choose which color I want, and I can go down here and I can choose green. So we're starting to set up that, okay, we've got the input which we want, which is a button. We've got a few different colors that we might want to send to the light, and we got the light. But how do we actually send these colors through? How do we get that input to connect to the light? Well, this is the real magic of SamLabs, is that everything is done in an incredibly easy visual way. So if I want the light to go red, for example, what I need to do is say that I'm going to send a signal from the button to the red color, and I'm going to send a signal from the red color to the light. And now when I press the button, you can see that that light turned red. If I just jump back into my camera here quickly, you can see that the light on this LED is red. It's a bit difficult to see, but you can see it off my hand there. So we've now actually successfully sent the signal from the button to the red color and to the light. We could do the same for the other colors, but that would mean that every time we wanted the color of the traffic light to change, we would have to reprogram it. Now, that's not very practical. You don't see people standing and reprogram traffic lights to let traffic through, right? So what we might want to do is set up some sort of a logic that allows us to toggle through the different colors. So for that, I'm going to need to do two things. First thing is I'm going to need to be able to choose how many times, or sorry, I need to be able to see how many times I've pressed the button. So I could say, when I've pressed the button 1 times, I want it to be red. When I press the button 2 times, I want it to be yellow. And when I press the button 3 times, I want it to be green. So I'm going to go over to my number section. So as you could tell, I was counting there. I was using the logic of numbers and that system to explore this. And I'm going to use my counter block, and I'm going to connect this to the button. And now, as I press the button, you can see that that is actually counting how many times I've pressed the button. If I want to reset this counter, I can go in and I can reset the counter so it goes back to 0. Now I need some sort of a block that can compare what that number is to a condition that I set up. So if I say, okay, when that counter is equal to 1, I want it to be red. So I'm going to use my compare block here, and I can easily say when the input or that condition is equal to 1, then I would pass it through. So if I now connect the system here, I could say when the counter is equal to 1, it's going to send the message to the red light and through to the RGB LED. But the light is already red because I connected it before. So that wouldn't be very exciting, would it, if I just made it red again? So what I'm going to do is actually set up my next 2 steps as well, which is going to be when this compare block is set to 2. And that means that when the counter is equal to 2, the light is going to be yellow. And one more condition, which is when the counter is equal to 3. By the way, we could also use different operators here, such as greater than, less than, greater than, equal to, not equal to, etc. So I'm just using equals to, which is a pretty basic one, but a very, very useful function to have. And we say when that's equal to 3, we're going to send the green color through. So now as I press the button, you'll see that first it gets a red light, then we're going to have a yellow light, and then we have a green light. The next challenge that we come across, and thinking back to this problem-solving aspect, which is really core to SamLabs, is that the problem is that we keep on counting higher. So we don't have any commands for when the count is equal to 8. So what we can do here is we can actually go into the settings of the counter. So if I go into the counter, I could say, I want the range to be from 0 to 3. And instead of actually 0 to 3, I'm going to make it, it's a little bit, oh, sorry, there we go. I want it to be from 1 to 3. So basically we have 3 different positions. And now when I keep on pressing the button multiple times, it's going to go 1, 2, 3, 1, 2, 3, and it's going to be toggling through those 3 different colors. Now, if I go back into my camera, I just want to show you that that is in fact happening on my block as well. So you can see that the color is changing as I'm pressing the button, moving through those different colors of the traffic light. Now, one of the things we could do then beyond this would be to actually automate this process so that as we start the system, it's going to just automatically toggle between these different colors by itself. So I don't need to keep on pressing because, again, in a real world scenario, you don't have people standing and pressing and changing the color of the light. It just runs automatically. So if we want it to be a really smart city, we can't just have someone standing there. So I'm actually going to add in an element of automation here. And for that, I'm going to need 2 different components. The first thing I need is something that keeps the system on. So the toggle here is a really useful function that keeps the system on or keeps it off. It basically has a true position and a false position. And I need something that turns that signal into a pulse, so that it alternates on, off, on, off. And for that, I'm going to use the interval. And again, you can see how easy it is for me to drag and drop and connect the blocks directly into that sequence. So what we have now is the button that's going to send a signal to the toggle. The toggle is going to switch from false to true. As long as that is true, that's going to be sending a signal into the interval, which goes false, true, and alternates at a particular timing interval that we've determined ourselves. And then that is going to keep that loop going between 1, 2, 3, 1, 2, 3. And I could go in here and I could change the timing of the interval, but I'm going to leave it at 1 second. I think it's pretty good for the traffic light. So you'll see that as soon as I start the system, it actually then automatically starts ticking through. And again, if I'm just jumping into my camera here, you can see that that is actually then flashing by itself and it's changing color without me pressing the button this time. So we've now actually got an automatic traffic light that is changing and toggling through those colors. But what you might notice now is that this doesn't really look like a traffic light, right? This is just an LED. So how can we make this look more like an actual traffic light? Well, this is where the makerspace becomes important, because I could have done this on my desk. Now, what we see at SamLabs is that when you start building the physical projects around the hardware, around these electronic components, that's when it really comes to life. So earlier in this week, I got my friend Julio to help me create a really awesome design for a little traffic light holder, and we actually 3D printed that over the weekend. And you can see that this little design here stands by itself. So it's got a little platform, so you can stand it up. It's quite a neat little design. And the great thing with SamLabs, and what makes SamLabs unique, is that this block is completely independent. It's wireless. It doesn't need anything hanging off it, doesn't need batteries, and that makes it so great for integrating into the 3D printed shape. So what we've actually done here is we've designed just a little hole for the block to fit into, and it's really important to have something that you can push it out with at the back so it doesn't get stuck in the design. Now what I can do is take my SamLabs block here and just simply squeeze that into my traffic light holder. And there, if I put that on a little surface, I actually then have a little traffic light that I can use. But and of course you could design your own shapes. This file is available to download as well, and you can customize that. There's loads of great designs out there for you to use. But one of the really key things is that SamLabs can integrate so easily in so many different ways because of that fantastic wireless shape. For those of you who haven't had the chance yet to see SamLabs in person, you'll know there's also a rubberized sleeve, which means that it grips that plastic really nicely. So you don't need to glue it in or tape it or anything. You can just slot it straight in. But there's also other ways that you can integrate the SAM blocks into different kinds of physical projects. We could do things like laser cutting. So in this case, I've laser cut a little spaceship, and I could say, you know what, actually, I want this to be a space traffic light, because why not? So in this case, what I could do is actually then I could stick this on with blue tack or something, and it'd be really easy to integrate. Or I could have designed a cavity for that to sit into as well. There's so many different ways you can do it, and it's really up to your imagination how you could create it. But thinking back into other integrations that we have, one of the great things with SamLabs is that all the kits ship with these Lego holders, and so these connector pieces basically allow you to snap the SAM blocks straight into any kind of construction material, such as Lego, and you do that just by squeezing the blocks onto the Lego pieces. And so what I did when I was making my traffic light was actually look at a few different options. So I've got my great 3D printed version here, but what if I wanted to make a quick prototype? Well, in that case, I've also made a really simple Lego version of that, and I could just set my traffic light on there, and then I've got a traffic light made out of Lego blocks. Or if I wanted to make it a bit more advanced, I could actually then do the same thing with Lego Technics as well. In this case, I've got a traffic light that I could raise or lower depending on what cars are coming by, whatever. So you can really start exploring that physicality of the project as well as the logic and the programming side too. So this really gives you so many different options of things you can build with. But it's not just all about 3D printing and Lego. There's also other great tools out there. If you look at other kind of construction materials, Strawberries is a fantastic one, lightweight straws. I built a little ball catching robot on top of the Curious car chassis with some Strawberries. That was really fun. But you can also build massive constructions and then put some sand blocks into that as well. It's only limited really by your imagination. And so as you explore these different tools, you can also start combining them. And so this is one of the coolest SamLabs projects ever built. It's a laser cut base with a laser SAM etched at the bottom, and then 3D printed parts. And this is a robotic arm that would move around using the servo motors. So really taking this engineering concept much further. This is for advanced users, but you can see how far you can take it when you start actually combining these different tools. Now, in terms of the SAM blocks that we would recommend getting into a makerspace, we have the fantastic Steam kit, which is designed to give you all the right blocks and hardware that you need for this kind of creative project. So this Steam kit comes in this fantastic hardy case. It's important when you're in a makerspace where this thing's flying around and things can fall over and so on, that you have a kit that not only slots and slides away nicely, but also is quite durable to protect what's inside. And I'm just going to show you some of the contents of the Steam kit as well. We have some great starter blocks. We have this Curious car components, but then we also have all the different hardware blocks down here, as well as Lego connectors and chargers, etc. Now, what the Steam kit provides is a great variety of different blocks. You've got things like a pressure sensor, which has this awesome little pressure pad at the bottom. So you can build projects that either measure weight, react to weight, like, for example, a smart coaster. That's a great project I've seen with the pressure sensor. You got a couple of sliders, you got heat sensor, light sensor, a whole range of different various blocks that really allows kids to explore and really come up with their own ideas and build those projects. So it really gives that variety that opens up for creativity and imagination. Now, one of the things that you could do in terms of taking that further as well is, as I mentioned at the beginning, is combining these different projects. So imagine if one of the students within this smart city project decided that they wanted to build a traffic light, but someone else wanted to build a car, say a self-driving car with a proximity sensor on the front of it, using, for example, the SamLabs motors. You can actually then link those projects together. So you could say, okay, when this car is driving down the road, it arrives at a sensor, and if the sensor detects the car and the light on the traffic light is red, the car stops, and it's only then able to drive again if it turns green. And what you're doing then is you're really actually starting to get that collaboration between the students. You start to expand and build bigger projects, and that's all powered by the SamLabs software being able to integrate these things, but also by the physical project that the students are building. Whether they're using the components from the Steam kit, whether they're using 3D printing, whether they're using Lego or laser cutting or whatever else they have around them, just cardboard, they're able to actually bring these projects to life. And what we find at SamLabs is when students bring these projects to life and they build things physically and they get hands-on, that really kind of embeds that knowledge and allows them to explore these things in a great way. So I just want to show you an area of inspiration as well, because one of the things that we often get asked is, well, what kind of projects can I build? You've talked about all these fantastic things that are possible to do, but where can I see some of these great ideas? Well, this is actually one of the things that we're working really hard on here at SamLabs, is providing you guys with structured content, lesson plans that you can take in and deliver in your class, but also little tidbits and ideas and fantastic things. So one of the great sources of inspiration is our lesson plan booklet. So even though these are meant for to be used in the classroom with more rigorous kind of step-by-step guides, they can also be a great source of inspiration that you can build on. So take, for example, the light chasing car. You can start with the ideas and lesson plan, and you can then elaborate on that and build that further. But you can also see great inspiration on our website. So I'm just going to jump in and show you where you can find these resources on our samlabs.com website as well. So if I jump in, this is our website, the homepage here. You can see some kids making some stuff. There's a great section for getting started. So if you want to get started today, you can download the app and you can see some of the resources there and how you get started with that. We also have a section here on projects, which I'll jump into, where it shows a variety of different things that are possible to do with SamLabs. So apologies for some of these pop-ups. And here you can see great examples from musical projects, car projects, Minecraft projects, really kind of spanning a whole range of different amazing things, using all sorts of different maker tools that you will have in your Makerspace, from Lego to cardboard to wood, and even other kinds of EdTech products. And then, as I mentioned, the lesson plans are freely available here on the website under the teaching materials section as well. So if any of this stuff was exciting for you and you're interested in getting started with SamLabs, we'd be very happy to reach out to you. You're also very welcome to subscribe to our YouTube channel so you can find the latest projects and use that as a source of inspiration. But there's several ways you can get in touch. You can reach out to us through the Get a Demo button, which is up in the top right there. And one of our fantastic SamLabs team will get in touch with you and schedule a one-to-one session going into more detail than we were able to cover today. You can also reach out to us on the live chat, so that's on the bottom of the website here. So there's several ways you can reach out to us right away. But you're also welcome to send us an email at info@samlabs.com or reach out to me personally at morton@samlabs.com. So we look forward to hearing back from all of you. Hopefully this has been a great little eye-opener in terms of the potential of using SamLabs within a makerspace. I love coming down here and putting together a few different ideas and testing things out and just making things, really. That's what it's all about. And we look forward to seeing all the fantastic things that you guys are going to make with SamLabs in your own makerspaces. Thank you so much for tuning in, and we look forward to seeing you next time.